Jason Hansman here. We're kind of missing a few steps in the story of technology. The book of Ezekiel, craft comes down, circle within circles, the spin metal circles within circles, with the light gleaming, and it was a big windstorm. So that's a mechanical gravity drive. Okay, if you've ever held a bicycle wheel or you get something spinning in your hand, right? You get it spinning, you try to move it around. It's like there's a force there. You know what I mean? And it kind of wobbles. It wants to coordinate itself with the gravity around it, obviously, which is at the center of our Earth or in space. There wouldn't be the force wouldn't be so prevalent. You might have kind of a washy area. Could be less traction, you could say, unless they're together. You could coordinate these drives together. Now, what it is a spinning disc. So in the book of Ezekiel, you have see how we draw this three-dimensionally. So say we had a circle, right? And there's a bunch of circles in a row. Okay, a bunch of circles in a row, and there's a platform in there. People, all right, dude's in there. He's happy. Okay. But they had a bunch of them. So we'll draw kind of 3D here, and this one would come like this. Actually, you know what? Do this a little better. We'll space it out a bit. So if we have one like this, okay, we have another one like this. These should be real. They're actual circles, but it's on a side angle, right? A platform's going through there, and this is coming down, and this is coming up. Okay, and same here. This one's coming down, this one's coming up, and then there's more. There's a platform that goes, through here. It's going right through here, right? There's a platform in the middle of these, right? Okay, so you can kind of understand what's going on here. It's kind of a angled version of this. So just turn that a bit sideways. And this one will be coming this way, and this one will be coming this way, right? So it's just spinning in a circle, right? So we have a platform here, and there's all kinds of stuff here. And actually, this one will be going this way. That one's going that way, and we need another one in this, and this. So that's going that way. So this one will be going the opposite way, right? So we can have balance. Now the point of this is on these circles, on this structure, so there's a platform, the circles all around it, right? And on this, you're gonna have little discs, okay? Discs, all the way around. And you're gonna wanna keep them, they're gonna have to rotate, you're gonna wanna keep them perpendicular to, the force you're trying to put, the downward force to give you lift, okay? So as these are on here, okay? The downward stroke, so as these are coming down, these start spinning, okay? These are all spinning. You might want to have them spinning in opposite directions, or you might want them all in the same direction. This is something the testing, the wind tunnel testing will answer for sure. Now, as they come down to here, these are spinning. And as they spin and they come down, what you're getting is a force, a lifting force. So this is going to come down, and it's going to want to lift here. And the same on this. So if on this side they're coming down, and then, might add, as they come up, the discs stop. There's no movement, okay? So you don't have a downward force. As they spin and come down, you get a lifting force, and as they rotate around to come back to the top of the craft, they are not moving. So there's no force other than their own mass and weight, being affected by the gravity of wherever you are, let it be here on Earth or in space. Now, of course, on the same thing on this side, to create balance, you have the same situation. Going up, this would be coming up, and there's no force there. But as this comes down, this is coming around, and now these are going this way, spinning whichever direction, and as long as they're spinning. So a circle is obviously the most efficient way to use energy. So there you have it, folks. That is our mechanical gravity drive. So some are spinning this way, and others are spinning this way, and then you have all the discs on here. And as they come up, or as these go down, they're spinning. And as these ones, and the discs on these ones, they're not spinning. But on the discs that are going the other way, so I think we can pretty much understand that. It's pretty layman's terms, very simple. But what really occurred to me, I've known about this, I've been talking to people about this for about a month now, or I came up with this, this came into my head probably about a month ago. I just haven't really put it on this. I'm waiting for someone to call me and give me a job, some physics stuff. So, if you're watching this, give me a job. I hope you appreciate it. I'm at work right now. I'm wearing these are my PPE socks, so Everyone's teasing me, but I forgot my work shoes. Anyways, so we're just having fun here at work, and the most important part about this gravity drive is it has to come before. For instance, for certainly it's like the gravity drive should come just pretty much after the bicycle, essentially. You know, we have rockets, we got battery power, we got electrics, then we got battery power, we got rockets. You know, we have aviation technology, and now we're trying to get into fusion drive. Well, we missed gravity drive, so this comes before, so now we have it. Now I got to spin some stuff around and make it spin. Battery, hook up a cord, whatever. But the biggest thing is Apophis, the asteroid they've been tracking, and it's supposed to come within our close to our atmosphere, within the radius of our moon. And what we can do with this technology is we can put these, we can land a machine or something on that asteroid. We can control that asteroid's rotation, and we can also control its trajectory by creating gravity fields on any part of the asteroid. So literally, we could use this technology to float around and have a great time, or scientific, or explore. But we could also use it to control an asteroid. And I also believe if you have these, you know, in a certain way in your craft, and you have, say, you know, these a certain way, you could put them in like a cone shape and have a gravity drive, mechanical gravity drive force in space, and you might be able to get up to some very extreme speeds that I think it would be mass and energy related. You know, mass versus energy. So the bigger the mass of these spinning discs, and the more energy you put in them, I think the faster you could travel. So this might even be faster to travel in space than electronic rockets with much less acceleration time. So the scientific value and the technological value to this type of stuff is, I think it's substantial. So it's to the world for free, but it's from me. And watch my video or give me a job at some university or somewhere with the Army.